All right, in this video I'm going to be talking about permutations. So first off, we should probably know what permutations are. So permutations are an arrangement of objects where, and this is the important part, where order matters. So the order that you put these objects in is very, very, very important. So permutations, order matters. And permutations are nice because there is a formula for it, and our calculator will do this formula for us. So the way we kind of read it is n choose r. So you have n total objects, you choose r of them. So the way this looks is we have npr, and this is going to be equal to n factorial, and I'll talk about that in a second, divided by n minus r factorial. Now, that factorial piece, so whenever you see n factorial, so for example, you might see like 3 factorial. That's not like shouting 3. What that means, 3 factorial, is 3 times 2 times 1. So you take whatever number you have and decrease all the way down to 1 and multiply it together. So 3 factorial is 3 times 2 times 1. So another example, 5 factorial would be 5 times 4 times 3 times 2 times 1. There is a special case there, though, that you need to know. 0 factorial is 1. Okay, so that is permutations. So I'm going to show you kind of 2 different ways to work through these problems. Some are formula-based ways, others not formula-based way. So it says, consider the letters in the word kindly, Kindly. Part A, in how many ways can you arrange all of the letters? So the first thing you have to ask yourself, does order matter? Does the order of these letters matter? Well, they do, because there is a difference between saying IN and NI. So order does matter. So in how many ways can you arrange all the letters? So how many total letters do we have to play with here? So we have 1, 2, 3, 4, 5, 6. So we have 6 choose, and that's my N. Well, how many letters am I choosing? Well, it says arrange all of the letters. So 6 choose all 6, N choose R. So in the formula, we're going to have 6 choose 6, which is kind of hard to see since they're both the same number, but those are N and R respectively. So we're going to have 6 factorial divided by 6 minus 6 factorial. Now, we could break this down and do all that if we need to, but again, I want to try and show you how our calculators can help us out and get us through. So, in your calculator, there is the permutation formula. What you're going to do is it's under the math button. Now, we are when we talk about permutations, we're talking about it as it relates to probabilities. So, we're not going to look at math, num, or complex. We're going to go all the way over to PRB, which is probability. And what you'll see is you'll see RAND, and then you're going to see NPR, and there's also NCR there, which we'll come back to that later. So NPR. So that's what we're going to use. But notice how it has the N first and the R second. So to use it, you need to type in your calculator the front number first, so 6, then go to NPR, hit that, and now you need the R point. Well, we're going to use 6. So 6 P6. Hit enter, and it's going to do everything for you and tell you that this is 720. Now, that is the permutation route to doing this problem, permutation formula-based route of doing this. Another way that you could do this, just because I like to show a few different ways if there are, is you could think of this in the case of, well, we have 6 letters, and they want to rearrange all 6. So we have 6 slots we have to fill. 1, 2, 3, 4, 5, and 6. Well, if I have 6 letters to use, and I'm going to rearrange them into 6 slots, let's go step by step and how many different letter options do we have for this first one? Well, I have 1, 2, 3, 4, 5, 6. So I pick one of the 6 letters, put it here. So one of my 6 letters is here. If I move to the next one, how many options do I have available? Well, one of my letters is already used here, so now I'm down to 5 available. Well, now I have 2 letters picked. How many options do I have available for the third one? I'm going to have 4, 3, 2, 1. So I had 6 options available. I used 1. So it's almost like you could think of, I put all these into a hat, pull out one, put it there. Well, now I have 5 options left. Pull out one, put it there. Now I have 4 options left. Pull it out one, put it there, so on and so forth. And if you take 6 times 4, 5 times 4 times 3 times 2 times 1, guess what? You're still going to end up with 720. So that's just another way you could think about these. Part B. So it says, in how many ways can you arrange 3 of the letters? So again, you got to ask yourself, does order matter? Yes, the order of letters does matter. That's how we have words. So ON is definitely different from NO, on and no, right? So the order still matters, so it's still a permutation situation. So how many ways can you arrange 3 of the letters? So we have 6 shoes. So I had 6 total letters, but this time I'm only going to arrange 3 of them. So 6 choose 3. So that's going to look like, in a formula basis, 6p3, which looks like 6 factorial divided by 6 minus 3 factorial. Now again, I'm going to go a calculator route here. I like to fill in the formula just to show, hey, I know how to do this. But, I mean, I hope we all know how to do 6 times 5 times 4 times 3 times 2 times 1. And do 6 minus 3 in the factorial. So I'm going to use the calculator here. So first thing I need is the 6. So I'm going to have 6. Math, go over to PRB. Oh, that's off the screen. 6. I typed in 6 first, went to NPR. And we have to choose 3. So 6 NPR 3. Hit enter, and I get 120. Now again, I'm going to show you the non-formula based way of doing this. So they want to arrange 3 letters. So we have to fill in 1, 2, 3 letters. Well, how many total letters do I have available for the first slot? Well, I have 6 available of kindly. Well, I used one of those letters, I filled it in. Well, how many do I have left for my second letter I could choose? Well, you're down to 5. Well, I've used 2 letters, how many do I have left? 4. So we end up with 6 times 5 times 4, which that is 30 times 4, 120. Notice how we get the exact same thing. All right, I'm going to show you one more example of a little bit more complex word problem. So we have 9 people, which includes Becky and Samir, and they're being interviewed for a scholarship. If the order is chosen at random, what is the probability that Becky will be interviewed first and Samir will be interviewed second? So again, you always need to ask yourself, does the order matter? Well, it already talks about order in the problem, and it talks about Becky being first and Samir being second. So being first and second, that is order. So this is still a permutation problem. And that's going to be important once we learn what combinations are. So they want to know, and another keyword I see in here is the probability that Becky will be interviewed first and Samir will be interviewed second. So remember, probability is we always have part over the whole. What's the part we're looking at? Well, we're looking at, well, what's the chance that we get Becky first and Samir second? And that's part over all total outcomes. So how many other ways we can pick the first and second person? Well, the way you can do that is let's figure out this top. So I got to choose Becky first and Samir second. Is there any other way we can do Becky first and Samir second? No, there's only one way to do that. Another way you could think of that is you're choosing 2 slots, choosing who goes first and who goes second. So this is just another way of thinking about it. Well, if I have to choose Becky first, how many different options for Becky do I have? I only have 1 Becky, so I just have 1. And I need to choose Samir second, so, well, the only option I have for him is, well, just only Samir. 1 times 1 is 1. But since this is a probability problem, remember we need to figure out what's the total amount of outcomes. So we're going to have 1 divided by the total amount of outcomes. Well, how many total people are we choosing from? Well, if we look back at the problem, we're choosing 9 people, or picking from 9 people, sorry, and we need to choose 2 because we're figuring out who's first and who's second. So we're going to choose 9 permutation 2. Well, we could go back and do that in our calculator. You know, you're going to do your 9 math all the way over probability, NPR, 9 choose 2, and we get 72. So what we end up here with is 1 over 72. Another way you could calculate that bottom of non-formula based approach is you're picking two people, right? So we talked about, well, you only have Becky and you only have Samir, one option for each of those. That's how we got the top. The bottom, what are all possible outcomes? Well, I have 9 total people I could have picked first. Well, once I pick one of them to go first, I lose an option, so I'm now down to 8. So 9 times 8, still 72, which is the same as what we got there. So we get 1 over 72 is the probability that we choose Becky first and Samir second. And that is permutations.